So good morning. So today we'll start from the last class, that is before puja vacation on 20th. 20th I have not completed one topic. From that point itself I'll start today. In between, maybe in the day before yesterday, that class was not related to your solid mechanics, but still it is very important from your competitive exam point of view. So from that equation actually I will give the flashback on that. Okay. So before going to puja vacation, we had arrived one equation. If you remember, del W is equal to del WE plus del WI is equal to 0. It was equation number 4. You remember? Is it not? Was this the last line on 20th class before puja vacation? Please respond. Probably this was the equation that we derived before puja vacation, if you remember. Am I correct or not? Am I audible? Hello?
Sir,
So it was the last equation on 20th. If you look at your note, okay. So we'll continue from this point, okay. So now you have to draw two diagrams. Simple diagram though. Two parallel springs. Okay. Suppose this point is A. So since this is A, this is also A. This is internal force F. Okay. Let us call this distance del 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 delta. Okay, very small displacement. And what is this? Initial equilibrium position of P. Initial equilibrium position of P. Okay, let us call this figure A. Now we have to draw the figure B. That means the free body diagram. Okay, so the free body diagram will be like this. The circle you have to draw. So there will be del delta, the reaction force F in the upward direction. This is point A. This is P, figure B. What is this figure actually? You have to give the caption. Fig. Partial displacement mass spring model. First to complete the drawing, then I will start writing. Is it done? Have you drawn the diagram or not? Have you drawn it?
Yes, sir.
So let us move forward. Okay. The equation 4 can be, you write the equation 4 can be interpreted by making reference to figure A, comma, figure B, where a where a weightless spring supports a rigid mass. This mass applies a force P to the spring and the system is in equilibrium. Then a partial displacement del delta is imposed on this system as shown in figure A. during this displacement. During this displacement, force P and internal force F shown on figure B. Figure B remains constant. Remains constant. As can be seen from the Freeboot diagram, this can be seen. This can be seen. Can be seen from the Freeboot diagram. Freeboot diagram means FBD, that is figure B. The external virtual work del WE done by force P is P L delta. On the other hand, the internal virtual work del WI. So this Saturday you will have quiz 4. I repeat, this Saturday you will have quiz 4. Same pattern. Done by F. Have I give you the answer keys for quiz 3? Have I given you the answer keys for quiz 3? Hello? Virat?
না স্যার
মই answer key বিলাক দিছো নে quiz 3?
নাই দিয়ে স্যার
I have not given, no? You have to remember. You have to remind me, okay? I'll give you, but before that, on day after tomorrow, we'll have quiz 4. Okay? See, if I don't give you the answer keys now, sometime I forget. You should remind me. Therefore, it is internal. Okay?
ওকে
Therefore, this internal partial group is negative. Therefore, this partial is negative. However, it can be noted that the work done by F acting on the spring spring is shown in figure A. Has an opposite sign. Therefore, by calling this internal partial work, caused by the external force as del WI it follows that del WI is equal to minus del WI. Put it equation number 5 by substituting substituting this relation in equation number 4. What we get? Del WE is equal to del WI. Equation number 6. Applying equation 6, the simple system in figure A. The simple system in fig A, E del delta is equal to F del delta or P minus F del delta is equal to 0. This relation is analogous to relation is analogous to E1 equal to, sorry, this is P2. This is P2 A2. Here L delta. This equation you have got probably in earlier classes. I have given you. If you look at the notes now, you will see here del delta is arbitrary. So P minus F is equal to 0, an equation of equilibrium. The partial displacement method partial displacement method for deformable system deformable systems expressed by equation 6. Establishes the equations for static equilibrium. It's essential to note that given a partial displacement the magnetic tips in direction of and directions of applied forces do not change. It is to be emphasized the constitutive relations do not enter into the derivation of Herschel-Rock equation. Herschel-Rock equations. Okay, now let us try to solve one or two small problem. Okay, I'll give you the question. You try to solve it here itself. So that we can call tutorial. Tutorial one. I'll give a simple problem. You try to solve here itself. Okay, let me draw one diagram. So all of you know that this is stress, this is strain. Engineering stress and engineering strain. Okay, suppose you have a curve like this, then it goes down like that, but it may be straight. Straight comes down, then remain horizontal. Okay, so you have to name it. What is the name of this curve? Okay, what is point Z? What it is? Suppose point F. What it is? E. What is it? Suppose this is D. You have to name. Okay. Suppose there is a point here B. Another point A. Suppose there is strain corresponding to this strain. Okay, so what it will be? Fine. Suppose you draw a straight line, draw a perpendicular here, and what is this? So now can you tell me what are the different points? Have you drawn it? Have you drawn it or not? So this type of problem I may ask you. Hello? Am I audible? Nobody is responding.
You're audible, sir.
But nobody is responding. All of you have drawn it or not? You draw it in your copy, then I will ask you one by one the different points. I will ask you. Okay, as you have drawn it, let me ask you one by one. Can I stop sharing? So I will ask randomly. See, this is very simple, huh? This is very simple. I have already mentioned about these things. Okay, Imna Temba, can you hear me? Okay, okay, you tell me what is point F in the curve. You can write in the chat box. What is point F? So this is actually mild steel stress diagram for mild steel, MS. So point F is Russell. Russell, what is point F? You can answer me by writing in the chat box also. I don't know, sir. Okay. So who know about that? What is point F? Anyone? Anyone can answer. Anyone can answer. What is F? Others?
Sir, making,
Hmm?
sir.
Breaking.
Making.
Necking. What point F is necking? No. See, that is the topmost part, no? Topmost point of the curve. So it will be your ultimate strength.
Maximum midpoint.
Huh? Huh?
Ultimate strength.
Yes,
Ultimate.
that is ultimate strength. You write down. Point F is ultimate strength. Write down properly. Point F is ultimate strength. Later you don't forget. Now can you tell me what is point G?
Breaking point.
Yes, fracture point. Right. All of you write down. Point G is fracture or breaking point or failure point. Whatever you say. Okay. Then what is the dotted curve? The curve would have been gone like that in the dotted line, but it has come down. After that it becomes horizontal. After that again become curves. Okay. But it should go on that dotted line, no, as I have shown you. So what is the dotted line actually?
True strength.
No, that is your true curve. That is the actual part of the, should have been actual part. So that dotted line is true curve. Are you able to write it?
Yes, sir.
Then what is point D? So point D and point E I will mention. Point D is your upper yield point, YIELD. Shall I write it?
Yes, sir.
Wait. Yes. So let me write now. Point first was point F, no? That is fracture point. Or you can say failure. You can say breaking point. Whatever you want to say. Sorry? It was Z.
So ultimate strength होगा sir.
Ha. This is Z.
Sir,
Hello?
F is ultimate strength.
Hello? What happened? It's coming, no?
Sir.
Huh?
Yes, sir.
So Z is the fracture point. Then F is the ultimate strength. That we call, what we call? Sigma UT or UTS. Ultimate strength. Sigma ultimate strength, that is the ultimate stress. Okay. So point D is upper yield point. This point. Upper yield point. Okay. So you write down point E is lower yield point. But this type of curve you will not get it for other material. This is for mild steel, mind it. So lower yield point. Fine. Then what is left? Then B. B is the elastic limit point. Elastic limit point. Okay. So that we can say sigma E. E for elastic. Then point B we can say proportionality limit. Lower yield point. Elastic limit. Okay. So point B is gone. Then point A is limit of proportionality, that is up to there Hooke's law is obeyed. That means up till there Hooke's law is followed or obeyed. Fine. So A, B, D, E, F, G, all points are done. Now what is left? Epsilon U. this point is called epsilon u, that is strain at the ultimate strength. Okay, this point is called strain at the ultimate strength, and this is your epsilon y, that is strain at the elastic point. Okay, now it is clear to you. And what is this figure actually? You remember, this is not correct for every figure. This is for mild steel. Stress strain diagram for MS, not Mahendra Singh Dhoni, mild steel. Okay, so are you clear about that? Are you clear or not? These points are clear.